Hello everyone, welcome to my channel. Today I'm going to discuss a past paper problem 2019 A-Levels Combined Maths Part A, problem number 5. So here we have to show that the limit of this expression as x goes to 3 is going to equal 1 over 2 pi. Okay, so what I'm going to first do, so I'm going to show you two methods to solve this problem. So method 1, so this is method 1. I'm going to multiply the numerator and the denominator by the conjugate of this numerator. So the conjugate of that numerator, this is square root x minus 2 minus 1. So its conjugate is going to be square root of x minus 2 plus 1. Okay, so I'm going to multiply that x minus 2 plus 1, and then I'm going to do the same thing in the denominator. So thereby it's like just multiplying by 1. So x minus 2 plus 1. And then if you look at the numerator, it's going to simplify. Square root of x minus 2 minus 1 times square root of x minus 2 plus 1, you will see that it's going to be x minus 2 minus 1. Okay, x minus 2 minus 1. And in the denominator, we'll have sine pi x minus 3. And then in the denominator, we will have this term, square root of x minus 2 plus 1. And we need to take the limit of this as x goes to 3. Okay. Now, let's look at the numerator again. So the numerator here is going to be x minus 3 sine pi x minus 3, and then here I'll have 1 over square root of x minus 2 plus 1, and again this is a limit as x goes to 3. Now what I'm trying to do here is that I know that limit as x goes to 0, this expression sine x over x is going to go to 1. Okay, when limit x goes to 0, sine x over x is going to go to 1. I'm going to try to build up a similar expression over here, and then try to apply as x goes to 3, that expression is going to go to 1. So I'm trying to build up that expression. So how am I going to do that? I'm going to look, this is what I'm going to do. I'm going to divide the numerator by that same expression, x minus 3. And then I'm going to do the same thing. I'm going to divide the denominator by x minus 3. Okay. And then look, I'm trying to create sine x over x here. So there's a pi here. So I need to, substitute a pi. So if I put a pi here, then I need to do the same operation over here. So then it's just, just like multiplying by 1. So now I have an expression. So let's simplify this expression and try to get something similar to this. Okay, so now let's continue. So this is that expression. My objective is to basically create this type of an expression over here. Okay, so now look at the numerator, x minus 3 minus x minus 3. So that's going to become 1. So limit x goes to 3. In the numerator, I have 1. And look at the denominator. In the denominator, I can have sine pi minus pi x minus 3 divided by pi x minus 3. Okay, and the pi here, I'm going to take it over here. Okay, that pi, I'm going to move it to here. So then I'll have this. So this expression is going to be pi square root of x minus 2 plus 1. And I'm going to put a parenthesis here. Okay, and then look. So this is taking the limit of this entire expression. So that can be broken down as taking the limit x goes to 3 of 1 and the limit x goes to 3 of this one. So 1 is just 1, it's just a constant. So there's going to be just 1, and then here I can have 1 limit x goes to 3, and here I'll have sine pi x minus 3 divided by pi x minus 3. Okay, and then I'm going to basically move that limit over here as well. Limit as x goes to 3, 1 pi square root x minus 2 plus 1. And then I'm going to substitute the limits. So here you can see this is similar to this one. So that's going to be just 1. Okay. So as you can see here, I'm going to squeeze my final answer here. I'll have 1 over 1. Okay. Why is it 1? Because limit x goes to 3, x goes to 3 sine pi x minus 3 over pi x minus 3 becomes 1. That's why I put a 1 in the denominator. And then multiplied by this one. So in the numerator, it's just 1. It's a constant. And in the denominator, look, limit x goes to 3. As x goes to 3, we have pi. And then here, look, that's going to be 3. 3 minus 2 is 1. So square root of 1 is just, again, 1. I'll have 1 plus 1. And then we'll have our answer as 1 over 2 pi. 1 over 2 pi. So the answer for this limit is 1 over 2 pi. And we have proven that it is the case. So the answer is 1 over 2 pi. And now I'm going to show you the second method, how to get this same answer. Okay, let's look at the second method to solve this problem. So for the second method, I'm going to use L'Hopital rule. As you know, in L'Hopital rule, you look at the given ratio, you apply the limit, and usually if it's undefined or indeterminate, what you can do is that you can take the derivative of the numerator and the denominator separately, and then apply the limit to that new ratio, and that's usually gonna give a defined value. If not, you repeat that process again and again. So that's the method I'm going to use as the second method, L'Hopital rule. So let's look at the limits of the numerator and the denominator separately and see whether they are defined or undefined. So you can see by visually when x goes to 3, the limit of this function, square root x minus 2 minus 1, just substitute, and then you can see the numerator is just 0. And then I'm going to do the same thing to the denominator. Limit as x goes to 3, I have sine pi x minus 3, and that's going to also lead us to 0. So then this ratio, limit x goes to 3, square root x minus 2 minus 1, sine pi x minus 3, this is going to be 0 over 0, which is undefined. So in that case, we can actually apply L'Hopital's rule. So I'm going to apply L'Hopital rule over here. Again, I look at the numerator and the denominator separately, I'm going to take the derivative of the numerator and the denominator separately. So that's the first thing that you need to do. So with respect to x, because the variable is x, I'm going to take the derivative of the numerator, x minus 2. Then the 1 is a constant, so that's going to be 0. But you take the derivative of square root of x minus 2, and there you will see it's going to be 1 over 2 times square root of x minus 2. Okay, so that's the derivative of the first term. And then the denominator, take the derivative of that sine function with respect to x. And then you will see it's going to be cosine function of the same thing. You see, it is a function within a function. And then you take the derivative of this function, that's going to lead you to pi. Okay, so those are the derivative of the numerator and the denominator. And now I'm going to look at the limits of the new ratio. Limit as x goes to 3, the same limit. And now I'm going to look at the new ratio. Okay, the new ratio is 1 over 2 square root of x minus 3 divided by this cosine function. I'm going to put pi to the front, cosine pi x minus 3, and then I'm going to substitute at the limit. You can see the numerator is going to be over here. I think I made a mistake. This is going to be a 2. That's square root x minus 2. So when I substitute 3 over here, the numerator is going to be just 1 over 2. And the denominator, you can see cosine, this becomes 0. So cosine 0. Cosine 0 is what? Cosine 0 is 1. So here I will just have in the denominator pi. Okay, so then you can see very easily at the limit x goes to 3, this new ratio is going to give us 1 over 2 pi. And that's the answer. So using the second method, that is L'Hopital's rule, we can get the same answer as we got in method 1. So that's how you do this problem, past paper problem from 2019 A-Levels Combined Maths new syllabus. Okay, thank you very much for watching my video.